You've likely seen or read or heard that hyperbaric oxygen therapy's got a range of different benefits that people can expect after going through a hyperbaric protocol. But you're still wondering, how does simply raising somebody's oxygen level systemically actually lead to all of those different changes that we see inside of the people who are using hyperbaric oxygen? Today, we're going to connect those dots, raising oxygen tension, leading to certain mechanisms of action. And those mechanisms are really behind the scenes, the root of the stimulation of all of the different benefits that people seem to experience once they go through a hyperbaric oxygen program. I'm Dr. Jason Saunders, founder of HBOT USA. I've been involved in hyperbaric oxygen for nearly 20 years, running my own clinics, doing research, teaching, training, and certifying practitioners and technicians in hyperbaric medicine. And my goal here with this channel is to share useful information to help educate the people interested in hyperbarics, making sure that hyperbarics remains safe and effective moving well into the future. In our last video, we talked about what hyperbaric oxygen is, how does it work, and what benefits might somebody expect as a result of going through a full hyperbaric program. If you're interested in that video, you haven't seen it yet, we'll leave a link in the description below. In our next video, we're going to talk about the range of different indications or conditions that people seek hyperbaric for. To be clear, it's not a treatment or a cure for any of those conditions. However, people with a variety of different conditions seem to benefit from hyperbaric, and we'll go over what that range of conditions might look like, as well as some sample protocols for what people might need as far as dosage over time to really get the results. In today's video, we're bridging the gap between how does raising the oxygen levels lead to these benefits. And we bridge that gap by talking about mechanisms of action. We raise the oxygen, that has certain impact physiologically, and those mechanisms are what are at play for people to experience the benefits that they see once they go through a hyperbaric protocol. If you didn't watch the first video, I encourage you, please take a look, because we went into detail on the science of hyperbaric oxygen and how and why it's so powerful and so unique. To summarize that very quickly, right now you're carrying oxygen in your body through red blood cells. Red blood cells are being saturated at the lung level, and they are being desaturated, delivering oxygen at the cellular level. If you have a healthy heart, healthy lungs, and you're living on planet Earth, which has an atmosphere, that atmosphere has a pressure. That pressure is what drives oxygen from the air you're breathing into your lungs and from the lungs into your circulation. Oxygen follows pressure, and so as we increase the pressure gradient inside of a hyperbaric chamber by increasing the pressure of the chamber and increasing the percentage of oxygen that you're breathing, that increased gradient becomes a driving force for supersaturating your circulation with oxygen. Saturating your red blood cells to 100%, that's easy. You're practically there already right now. What hyperbaric is doing is bypassing red blood cell carrying capacity and now supersaturating the plasma, the liquid portion of your blood, which normally right now is carrying very little oxygen. It becomes a reservoir of almost unlimited oxygen, depending on what pressure you're being exposed to, what percentage of oxygen you're breathing, and how long you are in the chamber in any given session. But now that we've raised the oxygen tension or the oxygen concentration inside of your body, what are some of those benefits that people will experience? Again, covered in more detail in that first video, we can see increased cellular energy production, reduction of oxidative stress, new blood vessel growth, reduced swelling and edema, improved mitochondrial function, improved mitochondrial size, shape, and even increased mitochondrial density, decreased inflammation, increased oxygen perfusion of cells and tissues. That high level of oxygen can help kill anaerobic bacteria. It increases the overall antioxidant quantity inside of our body. It helps us shift our epigenetic expression and repair DNA. It also helps to balance and regulate our immune system and stimulates the release of growth factors and stem cells systemically for the healing, repair, and regeneration of different cells and tissues. So today we're talking about how is it that this increased level of oxygen actually stimulates all of those different benefits. In order to understand that, we first have to understand that there's two very distinct phases of a hyperbaric treatment. The first is the time you spend inside the chamber, and the next is the time you spend outside the chamber in the first handful of hours after your hyperbaric treatment. Inside the chamber, we call that a loading phase. That's the time you spend under increased pressure with an increased percentage of oxygen, driving excess levels of oxygen into the plasma, and that's hyperoxygenation, increased oxygen relative to the amount of oxygen that you're able to carry right now. And there are certain cellular changes and benefits from that hyperoxygenation impact. The second phase is once you get out of the chamber. Once you get out of the chamber and now you've returned to normal atmospheric pressure, that increased level of pressure from the chamber is no longer holding that oxygen in your circulation. And as a result, that oxygen will leave your circulation and then interact with your cells and tissues in different ways than are typically possible under normal atmospheric conditions. So essentially, there's a loading phase and an unloading phase. And each of those have very distinct impact from a physiological standpoint. To help you better understand the mechanisms of action, I'm going to break them into 4 categories: mechanical, metabolic, immunological, and regenerative. And essentially, all of the mechanisms of action that have been well studied can fall into one of those 4 categories. Inside the mechanical category, we have 2 main mechanisms: decreasing bubble size and hyperoxygenation. The decreasing bubble size has everything to do with emergency dive medicine. That's the mechanism that we're really tuning into when somebody is scuba diving or working at pressure and has a rapid decompression. Nitrogen gas comes out of their circulation and starts to create inflammatory responses, vascular damage, neurological damage. It's not really something that we cover a lot in this channel, but it certainly is one of the mechanisms of action, and it's housed inside that mechanical category of hyperbaric. The other mechanism, hyperoxygenation, is certainly something we talk about and cover a lot on this channel. Hyperoxygenation is, quite honestly, one of the main reasons we're using hyperbaric. We are saturating red blood cells, but then we're supersaturating the plasma. We're creating a way to drive much higher levels of oxygen into your circulation that would otherwise be possible. That oxygen is then free to move into the cells and tissues that need oxygen for cellular performance and for cellular functions. I would also say that both of these mechanisms inside the mechanical category are due to the loading phase of hyperbaric, the time you spend inside the chamber, the pressure you're being exposed to, all of which are going to impact dissolving gases into solution, whether it's nitrogen gas back into solution because of an injury, or it's oxygen gas into solution for driving oxygen into the cells and tissues for nourishing them. The next category is metabolic, and metabolic has everything to do with your mitochondria and the usage of oxygen for energy production. If I was going to try to distill this down into the simplest of terms, you're eating food, which ultimately will become the fuel for the cell, and you're breathing air so that you can oxidize that fuel and actually extract energy from the fuel that you're eating. Not that dissimilar from a car engine. The cleaner and more energy dense the fuel is, the more power you can get from that engine. And the more oxygen you can drive in, the more power you can extract from that engine. So the type and quality of fuel and the quantity of oxygen play a critical role in that engine's performance. The mitochondria is the engine of your cell. Similarly, the quantity and the quality of the fuel that you put into the system impacts your energy production. And oxygen is really one of the most potent rate-limiting steps to energy production. And so as we drive higher levels of oxygen into your system as a result of the hyperbaric chamber, we're pushing more oxygen into the mitochondria, allowing the mitochondria to improve metabolism, and as a result, massively increase the cellular energy that you're creating from the fuel that you're putting into your mouth. Again, this metabolic component of hyperbaric has everything to do with the loading phase of hyperbaric. So the amount of pressure, the percentage of oxygen, and the time that you spend creating hyperoxygenation, driving cellular metabolism. So both the mechanical and the metabolic are very heavily reliant on the loading phase of hyperbaric. On the immunological side, we have a few categories to talk about. Number 1, high oxygen environments help to kill anaerobic infections. So as we drive oxygen levels up in your body, if someone's suffering from an anaerobic infection, that high level of oxygen through antibiotic synergy and breaking down biofilms, we are using oxygen to actually suppress or, in fact, kill certain anaerobic bacteria. We're also stimulating our immune system to better fight infection. So our white blood cells, which are in charge of fighting infection, use oxygen, specifically reactive oxygen species, as one of the ways that they fight certain viral and bacterial infections. And now we're arming the immune system with the tools that they need to help better mount an attack against whichever invader or infection we're trying to manage. Both this antimicrobial as well as this increased white blood cell activation are also heavily reliant on the loading phase of hyperbaric. On the flip side, inside of this immunological component, we have toxin inhibition, and we also have reductions in cytokine activity or systemic reduction in inflammation. And those two mechanisms inside this immunological category are actually a combination of the increased level of oxygen followed by a decreased level of oxygen, followed again in your next session with an increased level of oxygen and a decreased level of oxygen, and creating this wave of increased and decreased oxygen, stimulating those different pathways. And so those two mechanisms are actually reliant on both the loading phase and the unloading phase. Lastly is this regenerative category. Inside this regenerative category, we have growth factor releases, we have stem cell mobilization, we have tissue repair, tissue regeneration, epigenetic expression, DNA repair. This entire category is actually most heavily reliant on the unloading phase of hyperbaric. In other words, we see similar changes physiologically from hypoxia itself. So when you're getting low levels of oxygen, the body tries to make new blood vessels. When you have low levels of oxygen, your body's trying to adapt by increasing the mechanisms for getting as much oxygen as it can. And so we see stem cell mobilization, we see mitochondrial changes, we see blood vessel growth, we see neurogenesis, neuroplasticity. The body's trying to go through changes to maximize the extraction of oxygen in a low oxygen environment. And so that becomes counterintuitive. How does this hyperoxygenation therapy actually stimulate hypoxic-like benefits? And again, that's through this wave of increased and decreased oxygen. You go through a loading phase, an unloading phase, a loading phase, an unloading phase. Now, this could be done by going into the chamber and then leaving and then coming back the next day, going in and out, the next day going in and out. That would create a wave. It could also be done by taking what's called air breaks inside the chamber. Breathing oxygen for 20 minutes, taking it off for 5. Breathing for 20 minutes, taking it off for 5. Even though you're staying at the same pressure, the percentage of oxygen could be going from 95 or 100% back to 21. 95 to 100% back to 21. Also creating a wave. When we do that, we create these hyperoxygenation moments followed by this what's called relative hypoxia. So even though at no point in time during your session, and certainly at no point in time after your session, are you ever becoming actually hypoxic. What is happening is that compared to the amount of oxygen you had during the session or while breathing oxygen, during your air break or after your session, you're losing some of that oxygen. And while you're never becoming hypoxic, it's just a relative hypoxia compared to the peak oxygen you had during the oxygen exposure or during the treatment itself. That relative hypoxia is stimulating most of and maybe all of the same hypoxic pathways without actually having to expose that patient to hypoxia, which we also know have quite a few consequences to it. And so through that wave of hyperoxia, relative hypoxia, we are now stimulating these hypoxic pathways of new blood vessel growth, this growth factor release, this DNA and epigenetic repair, this cellular and tissue repair, neurogenesis, neuroplasticity, mitogenesis, and stem cell mobilization comes from creating those waves of increased and decreased oxygen levels. And so if we go back through the benefits of hyperbaric oxygen that we covered earlier in this video and at depth in video 1 from this series, we can start to understand which mechanisms are stimulating which benefits. So as we talk about increased ATP and cellular energy production, we can understand that that comes from the metabolic category of mechanisms of action. When we look at balancing or reducing the oxidative stress, increasing the antioxidant response inside of our body, killing anaerobic bacteria, or regulating the immune system, improving immune system activation, or reducing systemic inflammation altogether, we can understand that those are all coming from the immunological category inside of the mechanisms of action conversation. When we look at angiogenesis or new blood vessel growth, and we look at stem cell mobilization and growth factor release, well, we could start to understand that all comes from the regenerative category of mechanisms of action. When we look at reduced swelling and edema and changes in the mitochondria or hyperoxygenation, we can understand, again, those go back to the mechanical category inside the mechanisms of action. So today we're talking about how is it that raising oxygen levels inside of your body lead to those benefits, and we had a conversation around which mechanisms of action are actually taking place that stimulate and activate those different benefits. Some of these benefits are short-term benefits. They happen pretty quickly. Some of these benefits are long-term benefits. They take time to really elicit. So What are your health concerns? What are your health goals? What are you trying to achieve? Is it a short-term benefit or is it a long-term benefit? And what type of protocol or program should you think that you need to follow in terms of pressure, percentage of oxygen, and time that's going to give you the benefits to help you meet those challenges or exceed those goals? That's what we're going to cover in video 3, how to wrap this all together and create meaningful protocols based on what you're trying to achieve. Thanks again for your time and attention, and I look forward to seeing you in the next video. Maybe you just bought your first chamber, or you're thinking about buying your first chamber. Maybe that's a home use chamber, or perhaps you're considering offering hyperbaric inside your clinic. And if you're anything like me when I first started, you're realizing how much information there is out there, and you're concerned, are you doing this the right way? Are you being safe? How am I going to utilize this hyperbaric chamber in the most effective way possible? If you're just getting involved in hyperbarics and you're looking for an introductory training program, the basic hyperbaric technician program is exactly what you need. In this course, we're going to cover how does hyperbaric work? Why does hyperbaric work? What makes hyperbaric oxygen such a unique therapy? What mechanisms of action are taking place? What are the benefits of hyperbaric, both short and long term? And what types of indications are appropriate to utilize hyperbaric for? We will also help build your confidence, not only in how to utilize the therapy, but how to talk about this therapy with patients or with other healthcare providers that may not understand hyperbarics the way you will once you finish this course. So if you're ready to dive in, click the link below this video and let's get started.